Hello and welcome. We are Group 7 presenting Chapter 4 Supply Chain Coordination and the Use of Technology. After this video, you will able to understand a common supply chain dynamic that is major contributor to the boom to bust business cycle. Appreciate the factors that contribute to this supply chain dynamic. Evaluate ways to combat this dynamic. Assess technology that is available to support and enable effective supply chain coordination. Have you ever wondered how supply chain coordination is the use of technology related to supply chain management? Good coordination, supported by technology, ensure that products move efficiently from suppliers to customers. Reduces costs, improves delivery times, and makes the whole supply chain more responsible to changes. In short, technology makes supply chain coordination easier and more effective, which is crucial for managing supply chain. The Wu effect. The Wu effect is a phenomenon in supply chain management where small fluctuation in demand at retail level cause progressively larger fluctuation in demand at the wholesale, distributor, manufacturer, and raw material suppliers. In Tagalog, ang Wu effect is ang konsepto ng pamamahala ng supply chain kung saan ang maliit na pagbabago sa demand ng mamimili ay nagdudulot ng mas malaking pagbabago sa mga order na ginagawa ng mga retailer, wholesaler, distributor, at maging mga tagagawa. Sa madaling salita, habang palayo ng palayo sa pinagmula ng demand, lumalaki ang pagbabago ng mga order. The boom and bust business cycle. The boom and bust business cycles affects industries serving developing markets like telecommunication and computer components. It begins with high demand leading to product shortage, prompting manufacturers and distributors to increase products and inventory. Eventually, either demand changes or supply outstrip demand, resulting in an oversupply. When this becomes apparent, manufacturers may shut down operation and lay off workers, while distributors are left with differentiating inventories that can take years to sell off. Coordination in supply chain. Research into the Bull effect has identified the five major factors that cause this effect. These factors interact with each other in other different combinations in different supply chains, but the net effect is that they will generate the wild demand swing that make it so hard to run an efficient supply chain. This factor must be understood and addressed in order to coordinate the action of any supply chain. They are number one, demand forecasting. Demand forecasting is the process of predicting future customer demand for a product or service. It helps business make informed decisions regarding inventory management, production planning, and source allocation. Effective demand forecasting uses historical sales data, market trends, economic indicators, and sometimes qualitative insight. Accurate forecasts can enhance efficiency, reduce costs, and improve customer satisfaction by ensuring the right products are available at the right time. Number two is order batching. Order batching occurs because companies place orders periodically for amounts of product that will minimize their order processing and transportation costs. As discussed in the section of inventory control in Chapter 2, companies tend to order in lot sizes determined by EOQ or the economic order quantity. Because order batching, these orders vary from the level of actual demand, and this variance is magnified as it moves up the supply chain. The way to address demand distortion caused by order batching is to find ways to reduce costs of order processing and transportation. Drill cost EOQ to lot sizes to get smaller and orders to place more frequently. The results will be smoother flow of orders that will distributors and manufacturers will able to handle more efficiently. Ordering costs can be reduced using electronic ordering technology, transportation costs, third-party logistics suppliers to cost effectively pick up to many shipments for suppliers and delivering small orders to many customers. Number three is the product rationing. This is the response that manufacturers take when they are faced with more demand than they can meet. One common rationing approach is for a manufacturer to allocate the available supply of product based on number of orders received. Thus, if the available supply equals 70% of the orders, the manufacturers will fill for 70% of amount of each order and back order the rest. This leads distributors and retailers in the supply chain to raise their orders quantities artificially in order to increase the amount of product that gets rationed to them. Demand, and it's called shortage gaming. Number four is the product pricing. Product pricing causes product prices to fluctuate, resulting in distortion of product in demand. If special sales are offered and products prices are lowered, it will induce customers to buy more product or to buy product sooner than they otherwise would forward buy. The prices return to normal levels and demand falls off. Instead of a smooth flow of products through the supply chain, price fluctuation can create waves of discount. Number five, performance incentive. These are often different for different companies and individuals in supply chain. Each company can see its job as managing its position in isolation from the rest of the supply chain. Within companies, individuals can also see their job in isolation from the rest of the company. It is common for companies to structure incentives that rewards company sales force on sales made each month or each quarter. Therefore, as the end of the month or quarter approaches, the sales force offers discount and takes measures to move this product in order to meet quotas. This results in product for which there are no real demand being pushed into the supply chain. It is also common for managers within the company to be motivated by incentive that conflict within other company objectives. For instance, a transportation manager may take action that minimize transportation costs at the expenses of customer service or inventory carrying costs.
Supply chain and use of technology. Eliyahu Moshe Goldratt was an Israel business management guru. He was the originator of the optimized production technique, the theory of constraints, the thinking process, drum, buffer, rope, critical chain project management, and other thought derived tools. Eliyahu Goldratt wrote a book titled The Goal About a Factory, Manager's Quest to Save His Factory from Being Closed Down for Lack of Profitability. It, chronic- it chronicles the process that the manager and his staff go through as they learn how to save their factory. What they learn is how to apply the principle of what Mr. Goldratt calls the theory of constraints. The theory of constraints provides a useful model to conceptualize and manage the supply chain within a single company or across a collection of companies. The theory of constraints is based upon the idea that all systems have at least one system constraint and that is a better to manage constraint than to try eliminate them. This is because when one part of system ceases to be a constraint, a different constraint will occur in another part of a system. Once a goal has been defined and there is agreement on how to measure progress toward the goal, it is possible to apply the five focusing steps. These steps help clarify the situation being investigated and lead to the decisions necessary to reach the goal. The first one is identify the system's bottlenecks or constraint. Trace out the workflows and the paths that materials travel in a factory or a supply chain. Find out where slowdowns and backs up occur. The second is decide how to exploit these bottlenecks. Figure out how to maximize the operation of those activities that are bottlenecks. The rate of throughput for the entire system is set by the rate of throughput achieved by the bottlenecks. Ensure the bottlenecks operate at maximum capacity by providing them with enough inventory so that they can continue to operate even if there are occasional slowdowns elsewhere in the system. The third is subordinate everything else to the above decision. Do not try to maximize the operation of a non-bottleneck operation. Additional productivity achieved by non-bottleneck operation that will be neutralized anyway by the slowdowns and backs up caused at the bottlenecks. Synchronize all system operations to the rates that can be efficiently processed by the bottleneck operation. The fourth is elevate the system bottlenecks. Add additional processing capacity to the bottlenecks activities since the rate of throughput of the entire system is set by the throughput of the bottlenecks. Improvements in the bottlenecks will be increase the efficiency of the entire system and provide the best return of investment. The fifth is if in a previous step a bottleneck has been broken, go back to the first step as the capacity of the one system bottleneck is elevated. It may cease to be a bottleneck. The bottleneck may transfer to flow of work and inventory through a factory. The bottlenecks or constraint in the flow of work through this factory are operation C and A. The productivity set by these two operations step the phase for the entire factory. Productivity improvement in the other operation will not result in any improvement in the productivity of the factory as whole. Apply the five focusing steps to manage this system and move it toward the goal defined. Flow of inventory through a synchronized supply chain. Buffers in the supply chain are determined by the degree of uncertainty about future market demand and the service levels required by the market. The lower the uncertainty about demand, the smaller the buffers can be and still maintain high service level. Companies can manage their buffers by using either productive capacity or inventory, which is the most cost effective for them. Synchronized supply chains avoid the volatile waves of demand that are generated by the bullwhip effect, and increased predictability makes the productivity of each company easier to manage and the supply chain as a whole becomes more efficiently and profitable. The first one is raw material. A raw material, also known as feedstock, unprocessed material, or primary commodity, is a basic material that is used to produce goods, finished goods, energy, or intermediate materials that are feedstock for future finished product. The second is manufacturer. A manufacturer is a person or business that makes goods to sell. If you buy a shirt that has a made in the US label, it means that the manufacturer of the shirt is in the United States. The third is distributor, a person or company that supplies goods to the businesses that sell them. The fourth is retailer, the entity that purchases goods from a manufacturer, wholesaler, or some other distributor to resell it is known as a retailer. They sell goods to the consumer at a markup and earn revenue. The fifth is a market demand. Market demand refers to the total quantity of a good product or service that consumers are willing and able to purchase at given price within a specific market. The CFR process is divided into the three activities and planning, forecasting, and replenishment. Within each activity, there are several steps. Number one is collaborative planning. Collaborative planning is a dominant theory in planning in which multiple stakeholders come together to deliberate on common concerns and apply consensus building and public participation methods to make policies decisions. Negotiate a front and agreement that defines the responsibilities of the companies that will collaborate with each other. Build a joint business plan. that show how the companies will work together to meet demand. Number two is collaborative forecasting. Collaborative forecasting is a process where retailers and their partners work together to improve demand forecasting and inventory planning. Number three is collaborative replenishment, a set of practices in which trading partners plan key supply chain activities to efficiently meet customer demand at the lowest possible cost. Create order forecasts for all the collaborating companies. Identify exception between companies. Resolve the exception to provide an efficient production and delivery schedule. Generate actual orders to meet customer demand.
How to start a supply chain collaboration. To promote collaboration, measure the bullwhip effect within your company by comparing the volume and frequency of orders received from customers and those placed with suppliers. This can be done by plotting the divergence on a graph and analyzing the company's location in the supply chain. Many companies are unaware of the cause of the bullwhip effect on their supply chains, and it may be more efficient for them to collaborate to reduce demand fluctuations. Estimates of the cost consequences in different areas of the company, such as production costs, transportation costs, inventory levels, product availability, and order lead times, can help determine the worth of fixing the bullwhip effect. Executive insight. Historically, companies assign part numbers to items for easier buying and selling. However, with increasing competition and customer demands for faster and cheaper delivery, companies need to reduce costs associated with repetitive business transactions, such as purchasing, billing, account receivable, and account payable. Translation errors in part numbers cause confusion, errors were invoicing, and slow cash flow, affecting profit margins and consuming time. This trend is expected to continue and accelerate. Different part numbers for the same item can cause operational problems and a lack of accuracy in sales history data. Part number translation errors can result in undercounting or overcounting of sales, hindering demand forecasting, production scheduling, and inventory management. To improve coordination, companies need a single part number, the Universal Product Code or UPC, which is set by the Universal Code Council. Companies can use internal part numbers for internal operation but must use UPC numbers for communication. The Integrated Business Communications Alliance, or IBCA, offers a pragmatic solution for companies to start using UPC numbers in e-commerce. Information systems that supports the supply chain. Information technology aids internal operations and collaboration in supply chains through high-speed data networks and databases. It improves supply chain management and individual positions. Information systems perform data capture, communication, storage, retrieval, and manipulation functions with specific capabilities based on job demands. This system supports various aspects of supply chain management. Data capture and data communication. The first functional areas focuses on high-speed data capture and communication networks, overcoming lag times and lack of big picture information, thereby preventing the bullwhip effect. We will look at the Internet. The Internet is a global data communications network using IP standards, connecting all computers and devices. It allows companies to connect quickly and inexpensively, eliminating the need for expensive dedicated networks. Virtual private networks or VPNs provide extra data protection and privacy by utilizing the Internet to create secure communication networks. Second, broadband. This includes technologies such as coaxial cable, digital subscriber line or DSL, Metro Ethernet, fixed wireless, and satellite. Broadband technology is spreading and as it does, It becomes possible for companies in a supply chain to easily and inexpensively hook up with each other and exchange large volumes of data in real time. Most companies have connected themselves internally using local area network or LAN. Technology such as Ethernet that gives them plenty of internal communications capability. Many companies have connected some or all of their different geographical locations using Wide Area Network or WA. Technology such as T1, T3, or frame relay. Electronic Data Interchange or EDI. Electronic Data Interchange or EDI is a technology that was developed to transmit common types of data between companies that do business with each other. Many companies have large existing investments in EDI systems and find that it is very most effective to continue to use this system to communicate with the other business. Standard EDI datasets have been defined for a large number of business transactions. EDI systems can now run on any type of computer from mainframe to PC, and it can use the internet for data communications as well. Costs for EDI technology have come down considerably. Extensible Markup Language or XML. XML is a technology that is being developed to transmit data in flexible formats between computers and humans. Where EDI uses rigid, predefined data sets to send data back and forth, XML is extensible and when certain standards have been agreed upon. XML can also be used to communicate a wide range of different kinds of data and related processing instructions between different computer systems. There are many evolving XML standards in different industries, but as yet, none of these standards has been widely adopted. In the near term, XML and EDI are merging into hybrid systems that are evolving to meet the needs of companies in different supply chains. In the longer term, EDI will be fully consumed by XML as XML standards are agreed upon and start to spread. As these standards spread, they will enable very flexible communications between companies in the supply chain.
XML standards are widely adopted technology that allows for credible communication between computer system and humans. They can derive user interface and respond to human input, unlike EDI, which requires predefined data transactions and processing in sequence. The electronic industry has made the most progress adopting XML standards, with electronics industry beginning to implement Rosetta XML standards in the near term. XML and EDI are merging into hybrid system to meet the needs of companies in different supply chains. XML extension are being grafted onto EDI system, and service providers are offering internet-based EDI to smaller suppliers. In the long term, EDI will be fully consumed by XML standards, enabling spacious and free-form communication that coordinates supply operation on a daily basis. Data storage and retrieval. A database is an electronic storage system that organizes data, typically using relational database technology. This is database store related groups of data in individual tables and retrieve data using restricted query language or SQL. The database model represent the business processes for which it collects the stores data, balancing the need of highly urgent data with increasing cost detailed data. The database data model determines which transaction can be recorded in the real time or updating periodical batch of updating. Database also caters to different data retrieval needs of user, creating different combination of data called views. These views can created made available to users such as customer review of sales history for various products and customer. For example, a customer view might show products and quantities purchased or purchased of over time and detailed purchases at each customer location. Data manipulation and reporting. Supply chain system combine processing logic of for data manipulation and display with technology for data capture, communication, storage, and retrieval. The system handling of data depends on its specific business operation. Corfa and PEDAL define various types of information system supporting supply and chain operation. Enterprise sources planning or ERP system are essentially for supply chain management, gathering data from multiple functions within a company. They monitor other production schedule, raw material processes, and finished good inventory. ERP systems support a process-oriented view of business, allowing for comprehensive view of entire order fulfillment process. They come a models of finance, procurement, manufacturing, other fulfillment, human resources, and logistics focusing on daily transaction. However, this system often lack of analytic capabilities needed to optimize transaction efficiency. ERP system are essentially for effective supply chain management. Procurement system. Procurement systems streamline the procurement process between a company and its suppliers by replacing supplier catalogs with product database and tracks information like a part numbers, prices, purchasing history, and supplier performance. This system enables to comparison of price performance capabilities, identifying the best suppliers, establishing relationship, and negotiating prices, resulting automated routine transaction and purchasing process. Advanced planning scheduling. APS system are analytically application that access planning capacity, material availability, and customer demand. They create a schedule for production in plants and time using transaction level data from ERP or legacy system. Linear programming techniques are sophisticated algorithms and are used for creating the recommended schedule. For transportation planning system calculate material quantities and routes for transportation, allowing comparison of modes, routes, and carriers. Software is sold by system vendors while content vendors provide the necessary data like mileage, fuel costs, and shipping Taffirs on creating a transportation plan. Demand planning. Demand planning system used to historical sales data information about promotion to predict a future sales, revenue management, allow companies to experiment with different prices mixes based on predicted demand, aiming to maximize total revenue. These techniques is already used by airlines, rental, car agency, and hotel and travel industry and expected to spared by other industry. Customer relation management and sales force automation. CRM system automate customer service and customer acquisition tasks, storing customer data for easy access by sales and customer service. They track buying patterns history, enabling better response to customer requests. Salesforce automation system stimuli sales for activities, scheduling calls, follow-up visit, and preparing quotes and proposal customer and for prospects. For supply chain management. Supply chain management or SCM system are integrated suites of supply chain application including advanced planning, schedule, transportation planning, demand planning, and inventory planning. They rely on ERP or legacy system for data support and analytics capabilities, enabling strategic level decision making or SCM system can support advanced planning, scheduling, transportation planning, demand planning, like I'm saying, inventory planning. Inventory management system. The system aid inventory management by tracking historical demand patterns, monitoring inventory levels, and calculating economic order quantities and safety inventory levels for each product. They help companies to balance the cost of carrying inventory, which the risk of running out and losing sales revenue. And manufacturing execution system. Manufacturing execution system or MES is a less analytical system that focuses on factory for the production activities, producing short-term production and schedule and allocation resources within a single plan of produced by ERP or software vendors. Transportation scheduling system, similarly to ERP and MES applications, focuses on daily operational issues, producing short-term transportation and delivery schedule for companies. Warehouse management system. This system aid in daily warehouse operation by efficiently managing inventory levels, stocking location, and supporting action like picking, packing, and shipping products to fulfill a customer orders. Accessing technology and system needs. In evaluating supply chain system, it's crucial to consider company's goal of providing good service and good price to customers. Technology it means for a company to be of service to its customers and companies to prioritize this with succeed. However, technology is not end of self successfully supply chain management from delivering high levels.
Key business and supply chain integration. Based on this data sharing, opportunities exist to achieve supply chain efficiency and significant increase in the customer service and responsiveness. We are here to connect these different systems and provide the data across the extended supply chain. Many platform companies get themselves in trouble taking the data generated between their customer and using it into their economic benefit. But information integration refers to the capacity to exchange essential information between companies with a supply chain. This encompasses data like a history, demand forecast, information levels, and production capabilities, sales promotion, and transportation timelines. 2. Planning synchronization refers to the joint participation of companies in the supply chain in the demand of forecasting inventory and replenishment scheduling. It also includes the collaborative design and development and bringing to the market of the product. Number 3, workflow coordination. Follow planning, synchronization, and involve the optimization, automation, and continuous between process among the companies within a supply chain. This encompasses tasks like procurement and product development. Number 4, new business models can, can emerge as a result of supply chain integration made possible by the internet. Roles and responsibilities in a company's supply chain can be redesigned so that each company can truly concentrate on the activities that are important to exist and our non-core activities can be outsourced. Experience of the last several years. Since the late 1990s, e-business development has evolved through several ways. The first way focused on a user internet-based exchange to provide purchasing efficiencies and reduce product costs. The second way focused on the purchasing efficiency developed by the purchasing companies themselves, often through a consortium, consortium of big companies. The most recent way focuses on the achieving efficiencies in the supply chain operation like product design, demand forecasting, inventory management, and customer service. Information sharing are crucial of realizing This efficiency and cross-company coordination is essential to achieving desired efficiencies. Chapter summary. The text describes the bullwhip effect in a supply chain, which is which is the phenomenon of the amplified demand fluctuation moving backward through through the supply chain. It highlights the negative impact of this effect on the supply chain, coordination, and the needed companies and a collaboration to reduce it. Here are the key points from the text. Bullwhip effect. Small changes, customer demand at the front of the supply chain lead to the larger wings in the demand for companies further back. Impact. Misaligned demand perception and the breakdown in a coordination can result in a shortage and sustained supply. Costs. Many companies are unaware of the significant costs associated with the bullwhip effect. Solution. Companies can either improve their individual responses to demand fluctuation or collaboration to technology. Supporting technology is essential for effective supply chain operation, providing data capture, storage, and manipulation capabilities.